talking about teaching about Techquity.
Awesome. Thank you so much for having me, and thank you everyone for being here. I'm so excited to talk to you guys today about Techquity. I'm a former middle school teacher, and so I've thought a lot throughout my doctoral studies about what are the things I wish that I could have talked to my kids a little bit more about, and one of those things is Techquity. So to give you an idea where I'm coming from, today our world is full of technology. We all know that. Jan talked about that a little bit. It's on every street corner. It's part of everything that we use, and it tracks where we go and what we do. And in 1991, Mark Weisner predicted that technology would be ubiquitous, and I would wager that we have made it there to technology ubiquity. But as technology plays a role in each part of our life, the influence that it has started to disappear. So I challenge you to think for a second. Did you notice security cameras as you walked down the street today or yesterday, last time you were able to leave your house? Have you thought about the amount of information that's embedded in a magnetic swipe chip or the RFID chip that you scan across a door to get into your school? And how normalized has your phone been, like, in your pocket become? In 2019, so prior to COVID and our need to social distance, 4 in 5 American adults reported going online daily, and 1 in 5 American adults reported being online almost constantly. I know I'm one of those 1 in 5. The question is, are you? And the statistics of how often teens use technology and their level of technological connectedness is even greater. 88% of teens have access to either a laptop or desktop computer, and 95% of teens have access to a smartphone. In 2018, 45% of teens reported being online constantly, which is a 21% increase since 2015. And I would wager in the last 2 years that also has multiplied. So it appears that the younger you are, the more technology you're using. But these technologies sometimes don't work how we think they do. What are they really doing, and what are their purposes? How are they affecting us both overtly and covertly? For years, news story after news story has identified one problem at a time with technology. The news has reported violations to privacy, blatant racism that's caused by algorithms, and the pitfalls of well-intentioned or not well-intentioned updates. And together, these examples point to a larger systemic issue with the technologies that we and the youth of our society use compulsively. These issues are part of Techquity. So Techquity exists at the intersections of technology and equity, and I'm specifically focused on Techquity concerns. And just to clarify, Techquity is a term that I didn't make up, but I use. It's not a widely used term, but I'm working on making it there. So Techquity concerns are those aspects of computing and technologies that cause or could cause inequalities, especially inequality based on membership within a marginalized population. So marginalization due to race or immigration status, gender, sexual orientation, or ability. And within the K-12 CS framework, these concerns are directly related to the impacts of computing, and in this case, specifically focused on social justice and equity impacts of computing. And Techquity concerns are often interconnected. I want to go through some broad categories and examples of Techquity concerns to make sure we're on the same page, because I know that many of you have probably read a news article at one time or another about a Techquity concern, but might not think about them daily, which is natural. Our technology is created for us to think it's unbiased, and it runs without consideration. But there are many Techquity concerns, including algorithmic bias or the prejudice in the algorithms that underlie and control all of our technology, extensive data collection, particularly data collection that occurs without the knowledge of the user, the use of that data in targeted advertising, which is done by predatory organizations such as for-profit universities and payday loan companies, and is sometimes used in discriminatory ways against Black, Indigenous, and people of color, women, and other protected groups. facial recognition and voice recognition systems that work differently depending on the color of someone's skin, their gender, or their accent, technology accessibility, the underrepresentation of women and people of color on technology design teams, and the assumption that technology is unbiased. So today's youth are using technology at unprecedented levels, and that means they're being exposed to these Techquity concerns at unprecedented levels as well. And likely they don't know about the biases that are encoded into their very devices. And this is especially consequential for youth of color and those identifying as belonging to minoritized populations, because consciously and unconsciously, they're falling victim to Techquity concerns. So as we increasingly teach computer science to youth with goals of equity and broadening participation in the workforce, I propose that we also need to be teaching about Techquity concerns to prepare our youth to be critical consumers and potentially designers of new technologies. But the question is, how do you teach kids about Techquity? And that's a great question. It's what I'm working on right now. But it starts with informing students. Many people assume that technology is unbiased and attribute the harms caused by technology to how it's used, but this isn't the case. Technology creators and the data sets they use encode biases into technologies, and those biases will be exhibited no matter how technology is used. And so even if kids can't program a facial recognition technology, I wager that they can understand how facial recognition and machine learning work and how these different technologies are being used or could be used in negative ways against them, their peers, or their communities. So I want to talk to you today about two different examples of some Techquity lessons and how you could talk to kids about it. This first one is called Stump the Machine, and it relates to machine learning and facial recognition. I want to start by showing you part of a short video to introduce facial recognition and its potential bias. The video features a woman named Joy Buolamwini, who's discussing her work with artificial intelligence and facial recognition. She first got into this work because she herself experienced algorithmic bias when her own face could not trigger the facial recognition algorithm.
Hi, I'm Joy, and I research how computers detect, recognize, and classify people's faces. In my TED featured talk, I spoke about my experience with the coded gaze, my term for algorithmic bias. The system I was using worked well on my lighter-skinned friend's face, but when it came to detecting my face, it didn't do so well, until I put on a white mask. After my talk was posted, I tested my speaker image profile across different facial analysis demos. 2 of the demos didn't detect my face. The other 2, well, they misgendered me. The demos didn't even distinguish.
So I recommend the whole video, but it would take a third of my talk today. So, but I wanted to introduce that as an example of something that you can use to catch kids' attention, to start introducing these ideas. And it's a very real world example. But then there's a chance to have kids play around a little bit. And so a great way to do that is through Google Teachable Machine. Google Teachable Machine allows you to train your own machine learning algorithm to detect whatever you want. So, and you can use GIFs or sounds or different things as outputs. So it's very fun. I'm going to show you a quick video of me training it to recognize 3 different shapes. So in this video, you will first see me identifying 3 different classes of shape that I'm going to give: a red square, a green circle, and a yellow triangle. Then using my webcam, I give it 200 images of each thing. So each class is trained with 200 different images, so that's what'll go in. And so the machine then looks at that image, and that's how it quote unquote learns what is a red square, what is a green circle, and what is a yellow triangle. And you could do this with all sorts of things. You can make it know if you're giving a thumbs up or if you're waving. But I like this example I'll show you because after we've trained it, the goal is to stump it. And so it takes a couple seconds for it to run and to learn to do its quote unquote learning. And then you'll see I'm gonna check it with each of my shapes. So a red square, a yellow triangle, a green circle. But then I try to stump it. What happens when I give it a green square? Or a red triangle? So this starts to beg the question, what happens when it sees something that it hasn't been explicitly trained on? And this happens often with algorithms and machine learning. It's supposed to be able to start generalizing. So in this activity, kids can use these basic shapes to test out and try and trick the algorithm. In this case, the algorithm did well recognizing shapes that were included in the training set. It was able to recognize those with 100% confidence, and it got all of them right. But it wasn't able to make a correct identification and based when a shape wasn't included. And it based its identification on shape. So when I held up this green square, it was pretty sure it was a red square. Wasn't positive, but that's what it was identifying. It used the shape, but not the color. And so this opens up this simple example of misidentification opens up some conversations about what the implications are. In this case, a shape was misidentified, which isn't a big deal. But what happens if it's a person who's accused of a crime because facial recognition was used by a police department and now they've been misidentified? What are the surveillance implications of facial recognition being used? So this opens up some of those conversations for you to have with students and to start thinking about this from a simple example to more complex examples that exist and are used within society. The second activity that I want to share with you is an activity that relies on Google image searches to demonstrate bias within the images that are represented. So I'm going to show you a series of images that make up this activity. If I was doing this with students, I'd have the students run these searches on their own and kind of work through it more at their speed. But for the sake of a lightning talk, I'm going to just show you them. I do recommend if you do an activity like this that you use a private browser window because algorithms are affected by how Google has identified you. And so if you have a Google account and you're signed in, your results could differ from the person next to you's depending on how Google has categorized you. So private browser windows give you a more generic result. And this is, I do invite you to participate in the chat. I'm going to ask you some food for thought questions, so feel free to throw answers in there. We'll have a little audience participation. So this is a Google image search for teenager. And as you look at this image, what do you notice about these search results? And is there anything unexpected about them? And yes, Lorita, so it would be an incognito browser. If you're in Chrome, it's called incognito. If you're in Firefox, it's private. I forget what Safari is, but yeah, some sort of incognito mode is what you want. So thinking about this as teenager, here's the Google image search for baby. I'll ask you the same two questions. What do you notice about these search results? And is there something unexpected about them? Now let's look at some search results for professions. This is the search result for professor. And here's the search result for construction worker. Go ahead and comment in the chat. What do you notice about these results? I'm seeing a lot of people identifying there's a majority light skinned, majority men. What is the comparison of men to women in these searches? What about the number of Black, Indigenous, and people of color compared to the number of white people portrayed?
So Marika, you have about a minute.
Okay, I'll go quick. So the last thing is a search for 3 white teens. So this has been presented in the media, but so it's a little skewed. But if you look here, this last presentation is this is 3 white teens. And this is the same result for 3 Black teens. So you can then notice the difference And my big point with this is, as you guys have identified, that Google search results tend to show more white faces. They tend to show more men, depending on what you are searching. And it's not a short leap to imagine what these results for computer scientist or author demonstrate to a young Black girl who's dreaming of her future career. And so by making students aware of these Techquity concerns, we can give them language to call out bias and recognize the racist structures that are built into the very algorithms of the search engine or of the technology that they are using. These slides are in the folder, and all of these, there's a bunch more resources that I wanted to share with you, as well as write-ups of those 2 activities that I showed. And I'm happy to answer any questions.
You should feel free to unmute or put a question in the chat if you have any questions for Marika. And I just put the link to the her slides in the chat.
Thank you,
So
guys.
my question, I'm sorry, was just, I heard you saying kind of start there. Is there a curriculum? And I guess I'm kind of one of those people who like, I need to start with something. Is there, or is that in the folder already? Just something to kind of get me started thinking about where to start with this.
Yeah, that's a great question. There are a couple of resources. MIT has an AI ethics curriculum, and so that curriculum is really well done. It focuses specifically on AI, but a lot of these issues can be tied back to AI. There's also a teaching tolerance lesson that talks about data and how data is sold and used for advertising and different things. The 2 that I shared, if you go into the folder that's like my name for this talk, there's 2 Google Docs in there, one for each of those activities. Beyond that, I'm not aware of like a structured curriculum. My dissertation work is to try and build out a few of these lessons connected to computer science. So I'm happy to share those when they exist, but it'll probably be at the end of this school year, hopefully.
We'll have
my
you come
question
back,
is-
Marika.
I was going to say, my question is, once I bring this out or point this out to my students, what is there somewhere or something I can tell them what they need to do to combat it, other than wait a few years, you know, I mean, get into computer science right now, and then in a few years when you're in computer science, you can fight this battle. Like, is there something that they can be doing now to kind of help with this?
Yeah, so I'm going to put in the chat, there's something called the Data Detox Kit, which is, and this is designed for adults, so you probably want to think through a little bit of how to like think about this from a middle school perspective and not an adult perspective. But there are things you can do. You can shut off a lot of Google's monitoring of you and tell it like, don't use its ad preferences, and turn some of those things off. You can think about which browsers you're using. So using Firefox versus Chrome, using DuckDuckGo as a search engine instead of using Google. There are a lot of kind of, there's these small things that you can do to kind of create a more private thing, but something like the Google search results, unfortunately, we can't do anything about that right now besides advocate, speak up, call it out when it happens. The reason that 3 white teens, 3 Black teens image search is a little weird now is because it's been called out so many times. And so that's the stage where we're at with this. There's a lot going on within the computer science community of thinking about how do we get fairness and accountability within machine learning and facial recognition, but it's not there yet.